These are the notes on section 5.5, standard form. So far in the unit, we've already learned two forms of lines. Y equals mx plus b, which represents slope-intercept form, and y minus y1 equals m times x minus x1, which represents point slope form. The names of these two forms also reveal that slope-intercept form requires the slope and the y-intercept in order to write the equation of the line, whereas point slope requires 1 point and the slope to write the equation of the line. Today we're going to be working with the standard form of a line. Standard form is really useful for making quick graphs of lines. And before I explain what it is, I'm just going to show that standard form is always written ax, where a is a number, plus by, where b is a number, equals c. They're all numbers, so it'll be something like, as an example, 2x plus 3y equals 9. But I want to caution you right away, unlike slope-intercept and point-slope form, these numbers don't tell us the slope or the y-intercept. They can help us find some of those things really, really quickly and easily, but right away I want you to recognize that standard form doesn't reveal the slope or the y-intercept in the numbers that are in the equation. With slope-intercept form, we use the slope and the y-intercept to graph a line. With standard form, we're going to use the x and the y-intercepts. So we're going to use the y-intercept, which we already used, but we're also going to use the x-intercept. Before we do that, I just want to explain a little bit about how intercepts work. Obviously, looking at this graph, we can see that the y-intercept is here at 0, 3, and we can see the x-intercept is down here at 2, 0. You might notice that all intercepts will have a 0 as one of the numbers in the ordered pair. That's because for x-intercepts, you don't move up or down. You only move to the right. So the y value for all x-intercepts is always 0. And you can think about it. If I go to this point right here, that's 3, 0, or 4, 0. So for all x-intercepts, the y value is 0. If we think about it, for y-intercepts, we don't move to the left or the right. We only move up or down. So for all y-intercepts, the x value is always 0. And as we see here, this is 0, 3. If we went here, this is 0, 2, 0, 1. Again, so anywhere on the y-intercept, our x value is going to be 0. That information is important to recognize because we can also use it to find the x-intercept. If we know every x-intercept has a y value that equals 0, we can find the x-intercept by substituting in 0 for y, and then solving to find the x value. So let's try that down here in number 1. Again, we know the y value is going to be 0 to find the x-intercept. I'm going to write down for myself. Let's find the x-intercept. So then we'll have 6x plus 8 times 0 equals 16, and simplifying further, 6x plus 0 equals 16, and you'll notice that whatever is multiplied by 0 always is kind of overruled or canceled out by the 0. So we're just left over with 6x equals 16. From there, we just divide by 6, and we can end up with our x-intercept being at, if we simplified this, be 8 over 3, or 8/3. All right, so our x-intercept, to write it out, we can say is at 8/3, 0. To find the y-intercept, well, we'll do the same thing, but this time we'll put in 0 for our x value. Again, for every single y-intercept, the x value is always going to be 0. So this time we'll plug in 0 for x. So 6 times 0 plus 8y equals 16. I'm going to start, instead of writing 0 every single time, we'll be able to just immediately cancel that out. So we'll end up here with 8y equals 16, divide by 8 to get y equals 2. So our y-intercept ends up being at 0, 2. All right, take a second and find the x and y-intercept for number 2 using the same process. Again, for our x-intercept, we'll plug in 0 for y, so 2x minus 4 times 0. The 4 and the 0 are just going to cancel out, so we'll have 2x equals negative 6, or x equals negative 3. So our ordered pair would be negative 3, 0. Excuse me. For our y-intercept, again, the x value is going to be 0. So 2 times 0 minus 4y gives us negative 6. 2 times 0 cancels out. And when we divide by negative 4, our final answer equals 3/2. So for our y-intercept, it would be at 0, 3/2. All right. Let's try finding the y-intercept first this time. 7 times 0 minus 5y equals 10. And you'll notice I'm always labeling that I'm finding either the x-intercept or the y-intercept. It helps me organize in my mind, and for anybody grading me, what my work is showing. Negative 5y equals positive 10, so we divide by negative 5, and y equals negative 2. Written as an intercept, that would be 0, 2. Next, finding the x-intercept. Another tip or trick that you might be realizing is that if you're finding the x-intercept, there's going to be an x left over in your equation. And if you're finding the y-intercept, there's going to be a y left over in your equation. So our x-intercept is at negative 10/7 and 0. All right, so if it hasn't clicked in your mind, the reason that finding the x and y intercepts can be really helpful is once we have them, we can make a graph. So just to kind of look back up here, all I need to graph a line is at least 2 points. So these 2 points here are all I really need to connect and make this line. And I'm just kind of coloring it over darker to show that happening. So down here for number 1, if I see 3x plus 4y equals 8, we know that our x-intercept is going to be when 3x equals 8, and our y-intercept is going to be when 4y equals 8. You notice that I've just completely eliminated the step of writing 3 times 0 plus 4y equals 8, because the whole point of using standard form is to be fast and efficient. We know 3 times 0 is going to cancel out anyway, so to find your intercepts, you can start using standard form a lot quicker. We divide by 3 on both sides over here, so our x-intercept is at 8/3 and 0. On this side, we divide by 4, so our y-intercept is at 2, the point 0, 2. Okay, so now that we have those 2 points, 0, 2, we can graph quite easily. 8/3, I just take a second in my mind to consider. 8/3 is the same as 2 and 2/3. That would be fairly close to 3, but not quite there. And again, once I have 2 points, that's enough to graph my line. And we're going to start labeling all of our lines. So 3x plus 4y equals 8. That is standard form for that equation. All right, go ahead and try number 2 on your own, and you can unpause and check your work. So for the x-intercept, it would be 6x equals 12, and for the y-intercept, make sure to bring that negative. It would be negative 3y equals 12. Dividing by 6 over here, we'll get the x-intercept is at 2, or 2, 0. Dividing by negative 3 here, we'll end up with a y-intercept at negative 4, or 0, negative 4. Graphing our 2 points allows us to connect and create a line. Line wasn't perfect, but I'm going to let myself slide for now. I'll label it 6x plus 3y equals 12, and we're good to go. You can also graph horizontal and vertical lines using the same idea. Okay, so if we wanted to find where y equals 2, well, we know that's going to be on the y-axis. That's this point. right here as a starting point. Where else does y equal 2? Well, this point right here is 1, 2. This point right here is 3, 2. So we might notice that y equals 2 is going to end up being a horizontal line going across, showing all of the places where y equals 2. You might realize now that x equals 3. Well, x equals 3, that's going to be, if I went on the x-axis, that would be this point right here. So all the other places that x equals 3 would be other spots going up and down. If your mind gets confused, and let's say you thought, okay, I graph this point right here and draw a line this way. Well, if I went to this point right here, that's where x equals 1 and x equals 2. So that's a strategy you can use to just make sure you always draw it as either a horizontal or vertical line correctly. Okay, last thing is that although standard form isn't helpful, like point slope and slope intercept for finding information right at the beginning, it can be really, really helpful for giving us the intercepts, allowing us to make a graph, or changing back and forth to slope intercept form. So we need to be able to make standard form if we're given slope intercept form. You'll notice in standard form, ax plus by equals c. We always have the x and the y variables on the left side, and it's always equal to a number. It says right here, make sure to clear the equations of fractions if necessary. Okay, so when we have our ax plus by equals c, these numbers a and b have to be integers. We can't have any fractions. The same thing for c. C can't be a fraction either. In addition to that, we always have to make sure that our a value is positive whenever possible. So here we go. The first step to create standard form is to always move the x and y variables to the same side. So for this one, we'll have negative 2x plus y equals negative 7. If we subtract 2x on both sides, that moves it to the same side as the y, and then we can go from there. Last but not least, we're going to multiply by negative 1, just to keep the a term positive. So it would be 2x minus y equals positive 7. Both of these would have been accepted. So if you don't remember right away to get the a value positive, that isn't a requirement, it's just a preference. For number 2, we'll see that we both have to move the a term over to the left side along with the y. So we subtract 3/4 on both sides, negative 3/4 x plus y equals 12. And finally, we'll need to get rid of the fraction. So in this case, the denominator is 4, so I'm going to multiply all of the terms by 4. When I do that, I'm again also going to try to take that a term and make it positive, so I'll multiply by negative 4. Negative 4 times negative 3 over 4 becomes positive 3x. Negative 4 times y becomes minus 4y. And negative 4 times 12 becomes negative 48. So our standard form for number 2 would be 3x minus 4y equals negative 48. For our third problem, we'll start by moving the a term to the left side, adding 2/5 x to both sides. 2/5 x plus y equals 1. We know we have to get rid of any fractions, clearing them by multiplying by the denominator or common denominator. So multiplying 5 times 2/5 gives us 2x, 5 times y is 5y, and 5 times 1 is 1. So we'll end up with 2x plus 5y equals 5. So at this point, you should feel pretty confident on creating standard form from slope-intercept form. The final thing that we'll find standard form, is very helpful for is certain types of situations. So we've got the 8th grade class holding a fundraiser to buy Mr. Sanovica Super Bowl tickets, help him feel better after being out for a couple days. The PCMS teachers were all donating and all the supplies for a car wash that the students are going to be running. So when you guys make your car wash, you decide that the car is going to be $5 for a wash, and a van or truck is going to cost $8 for a wash. So your job is going to be to define variables, write an equation in standard form, and relate the total number of cars and trucks the students must wash in order to raise $2,400. As always, looking back through the problem, using the cubes method, you can circle these numbers here that are definitely going to be important. Underlining our question, it says to define variables and write an equation in standard form that relates all this information together. So first off, for our variables, we can think about the things that we don't know is, well, how many cars, we'll call that C, and then how many vans or trucks, we'll call that V, are going to be showing up to our car wash. We know that a car wash costs $5, so $5 for each car would be 5C. And we know that we're also going to make money from the vans and the trucks, which are $8 for each van or truck, so 8V. To figure out the total amount of money, well, we would add those two up, and if our goal is to raise $2,400, our equation would become 5C plus 8V equals $2,400. So just like that, we're able to write an equation for this situation due to standard form. Another nifty thing about this is that we can use the equation to find the intercepts. So 5C equals 2,400 and 8V equals 2,400. These end up being the extreme values. So like, let's say we only had vans show up. Well, if we only had vans show up, we'd need 300 vans in order to get to our goal. Over here, if we divide by 5, and I'm going to have to refer to my calculator. Not a good idea what the answer is, but I'd rather not make a mistake since this is going on YouTube. Ends up being 480. So if we just had cars, it would be 480 cars. That's the intercept 480, comma 0. And if we just had vans, it would be, well, 300 vans, or 0, 300. So the standard form is helpful for writing an equation, but it also helps us find the extreme values of a real-world situation. The last thing we'll need to do as a result of understanding standard form, which again we can say is ax plus by equals c, is how to transform between all three of these situations: slope-intercept, point-slope, and standard form. All right, so just as a recap, this graph, this equation right here, this linear function, which has a slope of negative 2/3, a y-intercept of 6, this point 3, comma 4, and the x-intercept at 9, 0, we can represent it in all three forms. So slope-intercept form, we'll take the slope right here, and the y-intercept right here, and we'll use those in our equation. In point-slope form, we again use the slope, but this time we introduce that point that was given to us. In this case, it was 3, 4, and we use the 3 and the 4 as the x and the y values in point-slope form. Lastly, standard form, well, we'll see that doesn't correspond exactly with any of the information that's given to us in the situation, but it is something we can create, and we can verify the x and the y intercepts. 2x equals 18 solves to be x equals 9, and 3y equals 18 solves to be y equals 6. All right, take a second, and well, if you're in class with a partner, but if you're not in class on your own, what would be the most efficient way to convert each of the equations into the other forms? Think about that for a second, and we'll do one together right here. All right, before we get going, I'm just going to take a second to kind of organize my work. To find point slope, we're going to need to have a point on the line, and we're going to need to find the slope of the line. To find slope-intercept, well, we're going to need to find the slope. Let me back up for a second there, and we're also going to need to find the y-intercept. All right, so at the beginning, we'll have to find either slope-intercept or point-slope form, and that will allow us to get to standard form. So I'll give you a hint right away that that will be the last form that we find usually. We already know 1 point, so I can say for point-slope form, we're well on the way. We have 0.13. We're going to need to find the slope. So I can quickly do my y2 minus y1, 5 minus 3 over x2 minus x1, which is 3 minus 1, resulting in 2 over 2, or 1, being our slope. Now that we have the slope and that point, we can write the equation, so which would be y minus our y value 3 equals our slope m times x minus x1, which in this case is 1. So finding point slope is usually the fastest and beginning point. From there, we've got a couple options. I think the easiest way is to find the y-intercept. Now that we know the slope and we have a point, we can use the equation y equals mx plus b. Plugging in for our slope, well, we can put in 1, and picking that same point, well, we have the point 1, 3. So we substitute in our x and our y, and that'll allow us to solve for b, or find the y-intercept. Solving further, 3 equals 1 plus b. Subtracting 1 on both sides, we end up with a b value of 2. If our y-intercept is 2, that means the equation would be y equals 1x plus 2. There is an alternate way to get from point slope to slope-intercept form, and I'm going to show that right here, which is simplifying our point-slope form. Y minus 3 equals 1 times x minus 1 can be distributed to be y minus 3 equals 1x minus 1. If we add 3 on both sides, we'll end up with y equals 1x plus 2, which ends up being the same thing that we solved before. Last but not least, to go to standard form, the fastest, most efficient way is always to take your slope-intercept form, subtract the a term, or move the a term if it's added. And then once your a and b terms are on the same side of the equation, this would be an acceptable answer, or it can be multiplied by -1 for a final answer of x minus y equals -2. All right, so just as a recap, whenever you're given 2 points, it's easiest to first find point slope. There's multiple ways, either using slope-intercept form or simplifying point slope to get to the slope-intercept form. And then we can use rearranging our variables to find the standard form of the equation. So go ahead and try the next 3, 4 on your own, and then the answer key will be posted inside of Google Classroom.